Alright, this section, or chapter actually, we're going to start now. It's all on radicals, so Unit 5. Before we get into coloring radicals exactly, we need to do a little review of some work from Math 1201. Where we're going to start first is with repeat multiplication, or with powers. So, alright, we take, say, numbers from 1 to 10. And we take 1 and we multiply it to itself twice. 1 times 1. Hopefully you remember that that can be summarized as 1 squared. Squaring means that you're doing 1 multiplied to itself twice. And here the answer would change, just be 1. And next you could have 2 times 2. And that will be represented by 2 squared. Or 4, 3 times itself twice. We'll just fix that. And that would be 3 squared, or 9. So I think you get the idea here. Then you can have 4 squared, five squared, and we will just continue here with each of them. And just to finish off, I have to fix that one above. 9 squared is 81. Oops. Okay, let me just fix this one, because that looks like it. It should be 64. Sometimes the 4s look like 9s when I write them in. And 10 squared. It's 100. And hopefully remember what these are called. So list of numbers that are squared, referred to as perfect squares. So we have all the perfect squares from 1 to 10. And the list would continue. It could go on forever. So what you're doing here, you're taking a number and you're squaring it. N would just represent any number. And it doesn't have to be just squaring. I mean, you could take a number and multiply it to itself 3 times. So you could have 1 times 1 times 1, or 1 to the power of 3. That's referred to as 1 cubed. 2 times 2 times 2. 2 cubed, or 8. You could have 3 cubed, 3 cubed. We'll fix that. 3 cubed, 27. 4 cubed, 64. 5 cubed, 125, and it will continue. And what we're doing, of course, we don't usually go beyond 5 cubed, but you know, if you need to find that you can, you just continue the list. And these would be called perfect cubes. So this again is a review of 1201. And actually, you could raise a number to any power that you want it. So if I want to keep this going, I mean, here it's a number cubed. We could do a number to the power of 4, 5, 6, 7, number to the power of 10. So you're not limited by that. I mean, if you want to do 1 to the power of 4, 1, 2 to the power of 4, 16, 3 to the power of 4. 81. So you can continue that as much as you want it. Where we continue on from here, where we look next is how would you reverse that? How do you go backwards? And to go backwards is what this chapter is about. So if I had 81, let's just pick 81, and I want to know what two numbers, or what number multiplied to itself twice gave me 81. Well, we could go down through our list of perfect squares and say, okay, well, that was 9 squared. You know it would be 9 times 9. So what number got multiplied twice? Well, we could say, was there 9 multiplied twice would give me 81, or 9 squared would give me 81. That procedure in math is called a radical. So here's the new part for you. So how you would write that is that you would say square root of 81. So this means what two numbers multiply to give you 81? 9. So let me show you one a little different though. What if I had this written? And here's where I'd like for you to take notice of something. The number 3 here written on just in front of the radical, well, not directly in front of the radical, but it's written on that little lip there of the radical sign. And by the way, this is called a radical sign. This is called the index. Okay, so what's the importance of that 3? And why didn't I write it over here? Well, for one, this is a different question. What this is asking you is, with the 3 written there, what number is multiplied 3 times? Or what number to the power of 3 is 125? So this is telling me that perhaps 125 is a perfect cube. And if I remember my list, then, 5. 5 times 5 times 5, or 5 cubed. So the answer here for this question would be 5. So why didn't I write it over here? Well, if you remember from this question, I want to know what number was multiplied twice. So I was looking through the list of perfect squares. If a numbers are written here on the lip, it's assumed to be 2. So you're expected to know that. So that now, if I have this square root of 64, this means what number multiplied to itself twice gives me 64, 8. And if I had something like this written here, cube root 64, well, what number has to multiply to itself 3 times to give me 64? The answer would be 4. So, just to recap, it's helpful to know your perfect squares, the first 10. If you can know the first 5 perfect cubes, anything beyond that you could find using your calculator. But having these committed to memory would certainly help. Number written in front or on the lip here, that's going to be called the index. This is called the radical sign. And underneath is called the radicand. And don't worry, we'll cover that in the next video.